Welcome to Brain Vision.
Our goal here is to evaluate this surface integral with the information that we're given. So the first thing we want to do is determine which formula to use. In this case, one that we could use, since we're given a couple different equations and functions, what we'll do is we'll use the double integral of f of x, y, g of x, y. And then this is going to be times the square root of the partial derivative of g with respect to x squared plus the partial derivative of g with respect to y squared, and then plus 1 dA. Now, with this formula in mind, we just have to find the other pieces. So now that we know that z is 1 plus 2x plus 3y, and we're given that we have the double integral of x squared yz, what we have now is going to be x squared yz, but instead of z, we'll multiply it by 1 plus 2x plus 3y, and then we will take the partial derivative of g with respect to x, and we get 2. Partial derivative of g with respect to y is 3, so we're left with this. We can pull this out right here. This would be the square root of 14, but it's not necessary for it to be in here, so we'll put the square root of 14 out here. Then we want to evaluate this integral. We can multiply it through, though, and what this is going to look like is x squared y plus 2x cubed y plus 3x squared y squared. And now we just need to determine our bounds of integration. We know x goes from 0 to 3 and y goes from 0 to 2. So we'll call this dy dx, and this will be from 0 to 3. As long as we put this right here in parentheses, we can evaluate this double integral, and we get 639.82. More specifically, if we were to evaluate this integral one at a time, we would end up with 171 times the square root of 14. So we know that this right here would all evaluate to 171, and then the square root of 14 we had already found. And we notice that this matches both what we already solved for, so we can be confident in our answer. And that's just how we do surface integrals, using potential different formulas and solving for important elements in order to evaluate that integral.